Hello. Today, we are assessing whether our upcoming manufacturing line should continue using our current closed die forging process or whether we should invest in a newer, advanced option, powdered forging. In this, we will take a closer look on how both processes function and compare them in terms of process considerations, advantages, limitations, and production costs. We will then talk about a brief manufacturing readiness level assessment to help determine whether powdered forging is an appropriate direction for our company, or if it would be more practical to remain with the widely used conventional closed die forging approach. Starting off with closed die forging, a heated metal billet is placed between two shaped dies and plastically deformed to the desired form. The billet is heated to improve workability, and a lubricant may be applied to reduce friction and extend the life of the tooling. The top die is then driven down with high pressure until the cavity is filled, ensuring that the material flows into all necessary features. Forging high temperatures results in clean final surface and often minimizes the amount of finishing work required. Powdered forging begins by selecting the required metal powder and compacting it into a precise die to form a green preform. The preform is then centered below its melting point so the particles bond and harden, creating a structure that is strong enough to be handled, but is still not fully dense. Once centered, the part is reheated and forged in a die for final shaping under pressure to achieve the maximum possible density for that chosen material. Now, some advantages of both closed die forging and powder forging. Starting off with closed die forging, it provides strong mechanical performance because the grain flow follows the part geometry, which significantly enhances fatigue resistance and overall durability. This enhanced strength makes it ideal for applications where reliability and structural load are priorities, such as automotive and aerospace components, and it also supports a wide range of part sizes. Additionally, the dense microstructure produced by forging reduces the likelihood of internal flaws, contributing to consistent performance even under demanding conditions. Powdered forging offers advantages in producing durable, high-temperature components with less manufacturing difficulty. It also supports high production rates and near-net shape forming, reducing machining time and minimizing scrap. Because the process utilizes controlled powders, and sintering temperatures, manufacturers can more precisely control density, hardness, toughness, and even magnetic properties than with conventional forging methods. Now, talking about some disadvantages, starting off with closed die forging. Closed die forging has limitations because of microstructure control, is less precise compared to powder-based processes, which can be engineered at the particle level. The process also struggles with highly detailed geometries, and many parts require secondary machining to achieve tight tolerances. Additionally, design changes often require new dies, making the approach less flexible for low volume production. Now, powder forging struggles with part sizes that are limited, or part sizes are limited, and most commercial presses top out near 40 to 50 square inches, which restricts the range of components that can be produced. Complex shapes can also be challenging for inexperienced operators needing precise process control to prevent defects. Most importantly, powdered forged parts typically do not reach full strength and ductility compared to traditional fully forged or cast iron components. Now here's two examples of connecting rods, both powder forged and closed die forged. As you can see from the pictures, other than the small discrepancies that are there because of how they wanted it to design, they are pretty much similar on the outside. This is showing us that most of the differences are within the properties of the parts.
We will now look at the cost comparisons between the two manufacturing processes. Advantages that powder forging has over closed die forging is that there is virtually no material waste when a powder forging process is complete. Powder forging also has a cost advantage in being the more precise process. If there are complex parts to forge, there will be less material waste and it will take less time to form, which will develop a lower cost. Closed die forging has advantages in normally requiring less post-processing machining to gain desirable surfaces or dimensions. It is also cheaper to buy conventional bulk material instead of powder feedstock. There is a workaround to this problem, and it would be to use scrap machining chips as feed for the powder to forge instead of conventional metal powder. Studies have shown that this can lead to a 25% decrease in material cost. If the feedstock cost is closely managed, powder forging can have significant cost advantages in material utilization and waste management. The part geometry must also be favorable for the process as well. Next, we have prepared machining readiness level topics for a powder forging process. Firstly, if powder forging is to be used, it must be determined that the parts will be the correct size. This means not going over the 40 to 50 square inch limitation. It would also require new equipment to move into a powder forging process, including a powder metallurgy press and sintering furnaces. The existing conventional forges can be used for part finishing. Demand for powder metal is very high right now as the industry continues to grow from advancement in new research and mechanical technology. Pricing for steel material powder is around 12 cents per gram. If the part can be made with a weaker material, iron is a cheaper option. As mentioned before, scrap metal chips are also a cheaper alternative, but the parts may require more post-machining if done this way. The complete production cost will also include the cost of labor, tools and die cost, and indirect costs from other processes. The biggest safety risk from the powder forging process will be the fire risk from the metal powder and dust. This dust will also be able to cause eye and skin irritation to workers if not properly dressed. There will need to be schedules created for an accurate projection of parts created per week and month, also to maintain efficient use of the powder material. Dimensional requirements will be set on a part-by-part basis either by our team or the buyer of this part. After all the research done between the two processes, we recommend that the company switch to the powder forging process for all parts that can be made within the size limitations. Based on space requirements, it will be best to keep as many existing forges as possible for finishing and the possibility of still keeping contracts that have parts too big for a metallurgy press. This decision is made to increase the production capacity of the units while maintaining high precision on part shapes. Thank you for listening to our presentation on powder forging research and how it will look for our company. We believe this process can be key to improving our company's total production and profit.